that the answer is not going to be because it makes things easier every time, which a lot of you wrote, which I knew would happen, which is why I said yesterday, the answer is not always because it makes it easier. Again, that's just an answer not thinking, just being like, oh, yesterday it's always easier, so I'm going to write it makes it easier today. Is that really thinking about it or just saying, oh, well, that was the answer yesterday, so I can just write that? No, because if you think that, you don't even go back and read the question. You read the question halfway, and then you're like, because it makes it easier. That is not always the answer. And if you do write because it makes it easier, you need to write, how does it make it easier? So right now, every single person, you need to go to number 33. You do not have to cross out your answer, but you do need to get out your pencil. Actually, no. Quickly get out your red pen. And you need to write this answer so that when you are answering today's independent practice question, you can go and look at that and be like, okay, well, this was the answer today. And then eventually, you will have example answers to help you answer new questions. But you need to make sure that you are thinking about it, not just picking a random answer. Yes, Carla? Okay, I can look at your, but I want you to write, I want everybody to write this. Do not cross out your answer. That's why I said, because you may have a good answer that's just a little different. Well, now you have multiple examples of how to answer these questions. So it says, patterns in mathematics give us clues to changes in numbers. Yes, Ethan? Well, then you have space. You have some space here. You have some space here. Just make it work, but you have to be neat so that you can still see your answer and the other answers. Kingston, are you doing this? Because we don't have time to wait. Patterns in mathematics, you can say math, patterns in math, give us clues to changes in numbers.
Did we write the bottom too? Did we write the bottom?
But I'm reading this one so that people, if they can't see, but this is as big as I can make it, so. Patterns in mathematics give us clues to changes in numbers. Changes in numbers can help us to solve problems. So you need to write both sentences. Changes in numbers can help us to solve problems is the second sentence. Yes, Carla?
I don't have enough space.
Then do what I just told Ethan to do, which was find the space.
Miss Phyllis, I can't see the board.
That's why I'm reading it several times. I can't make it any bigger. Patterns in mathematics give us clues to changes in numbers. Changes in numbers can help us to solve problems. And if you're, girls at home, if you're watching in speaker view instead of gallery view, then my window will be bigger so you can see the problem bigger. And because you're not speaking, it should not switch windows. So it says again, patterns in mathematics give us clues to changes in numbers. Changes in numbers can help us to solve problems. Girls at home, watching in speaker view instead of gallery view will also help to be less distracted by the other girls in the video or in the Zoom call. I'll read it one more time, and then we're going to move on to today's lesson. Patterns in mathematics give us clues to changes in numbers. Changes in numbers can help us to solve problems. Okay, so once you're done writing that answer, go ahead and turn to page 79. Turn to page 79. I'm going to go change the page. We're on page 79. So you should be on page 79. And before we begin, we're going to be doing some rounding and addition in this lesson. So let's practice and let's round a couple times. So if I have the number 79,432. And I round it to the nearest thousands place. Remember, step 1, circle the digit in the place to be rounded. Step 2, underline the digit to the right. Step 3, if the underlined digit is 4 or less, I keep my circle digit the same. If my underlined digit is 5 or more, I add 1 to my circle digit. Well, in this case, my underlined digit is 4 or less, so that means my circle digit stays the same. Before we keep moving, how many zeros am I going to have at the end of this number? Michaela? 3, because step 4 is everything after the circle digit becomes a 0. I have 3 digits after the thousands place, so that means all 3 of those digits become zeros. And don't forget step 5, anything before the circle digit stays the same. Our unofficial step 6 is to place our commas every 3 digits. 1, 2, 3. 1, 2, don't need another one. So 79,432 rounded to the nearest thousand is 79,000. Well, what if I have 42,921 and I want to round to the nearest hundreds place? Carla, very quickly, what's step 1?
Step 1 is to circle the digit that you're going to round.
Okay. So which digit am I rounding? Which
9.
digit am I circling?
9.
9. Step 2?
Step 2 is to underline the number in front of the circle digit.
In front of it?
No, I mean behind it.
So to the, what direction?
Right.
Right. Good. Which is a
2.
2. Carla, good. I can tell you memorized these. Good job. Now step 3, Carla, my digit is 4 or less. So what do I do to the circle digit?
You leave it alone.
I leave it alone. If my underlined digit had been 5 or more, what would I have done to the circle digit?
You raise the score.
I would raise it, so I would add 1. Good. Carla, how many zeros am I going to have at the end of this number?
2.
2, because step 4 tells us that what? What does step 4 tell us to do?
Step 4 tells us to make the other numbers behind it.
Behind what?
0.
Behind the underlined digit or behind the circle digit?
Behind the circle digit.
They turn into what?
0.
And then step 5 tells us what to do. What do we do with this 4 and this 2 at the beginning?
You put it in front of the 9.
Good. And then our unofficial step 6, we put a comma every how many digits?
3 digits.
3. 1, 2, 3. 1, 2. So that means 42,921 rounds to 42,900. I'm going to leave that. I'm going to do one more. And Zadie, you're going to help me. Zadie, give me a 5-digit number. Quick.
5,000.
Is that 5 digits? If it's 5,000? You can use 5 at the beginning, but it wouldn't be 5,000. It would be
52,335.
good. Now, which place should we round to, but not the thousands or the hundreds? So we can do 10,000s or tens. Which one?
Tens.
Hey, Zadie, how many zeros are going to be at the end of my number?
1.
1. Let's find out if you're right. What's step 1?
Circle the digit in the place to be rounded.
So which digit are we circling?
The 3.
The first one or the second one?
The second one.
Good. Step 2,
Underline the digit to the right.
which is a
5.
this one or this one? First one or second one?
Second one.
Step 3, is our digit 4 below or 5 or above?
5 or above.
So what does that mean?
Take the circle digit and add 1.
So our 3 becomes a
4.
step 4,
All the digits behind the circle digit become zeros.
so we have how many digits after the circle digit?
1.
So how many zeros?
1.
So were you right?
Yes.
Good. But are we done?
No.
What is step 5?
All the digits before the circle number stay the same.
Good. And our unofficial step 6?
Every 3 digits have a comma.
Good. 1, 2, 3, comma, 1, 2. Don't need another one. If I took a number and I rounded to the 10,000s, how many zeros would I have at the end? Michaela? If I took a number and I rounded to the nearest 10,000, how many zeros would I have at the end, Michaela? Try again. I think you just didn't hear thousands. So if I took a number and I rounded it to the nearest 10,000,
5.
not 5, because that would mean every digit changes to 5. Aaron?
4.
4. Because remember, whatever place I'm rounding to, every single digit after it will be 0. No matter what. Always and forever. Whatever place I'm rounding to, every single digit after will be 0. Okay. Go ahead and look at example 1. Finger or pencil on example 1. When I see everybody's finger or pencil on example 1, we will continue. Make sure that you are focusing and following along, because if you are focusing and following along, this lesson will be one that will not take you a long time to do. Okay. Oh, let's read the sentence above. I forgot, I don't have it because it's one sentence. Please read the sentence below the title, Cullen.
When estimating, you can round to any place value.
So all that means is it doesn't really matter which place you round to. Any rounding, you can choose any place to round to except one. There's one place you cannot choose to round to. I don't think I've mentioned this, so let's see if you can come up with it just based on what you know. Aaron?
You probably couldn't round in the ones place because there's no digit afterwards.
Exactly. If I tried to round to the ones place, well, I can imagine that imaginary 0 in a decimal place, which we won't learn until later, which no matter what. So if I had 781 and I rounded to the ones place, well, I can imagine an invisible 0 after that decimal point, which we'll learn later. Doesn't really matter right now. Well, I circle the digit in the place to be rounded. I underline that invisible 0 to the right. Step 3, we're only ever going to have an invisible 0 to the right if we have a whole number. So that always means the ones place would stay the same. So we can't round to the ones place, because if we tried to round to the ones place, we'd end up with the exact same number. And is that estimating when you're getting the actual exact same number as what you started with?
Nope.
No.
No.
No. Because estimating, you end up with a number that is close to your original number, but not the same. So we can round to any place. Carla, please pay attention. Please put that away. You don't need that right now. Please put it away. So I want to see your hands. Thank you. We can round to any place in a number except the ones place if we have a whole number. So that means this lesson won't necessarily tell you what place to round to. You get to choose. You get to choose. So now, everybody, finger or pencil on example 1. Read in your head, excuse me. Read in your head while I read out loud. The Central School District needs 5,481 forks and 2,326 spoons for a school function. About how many forks and spoons will they need altogether? I forgot, we want to read it first and then go back and read it a second time to find our important information. Because if we try to circle the important information at first, we might accidentally put a box around a number that isn't actually important in our problem. So we're going to read it first, then we're going to go back and find important information. So we just read it, now we can go back and put a box around important information. The Central School District needs 5,481 forks. I know that's important because my question says how many forks? And 2,326 spoons. I know that's important because my question also says the word spoons for a school function. For a school function, I don't really need to know what they're for. I just need to know how many I need. Then I have my question about how many forks and spoons will they need altogether? Now, about is an important word because it tells me to estimate. If I see a question that has about how many, that means I'm not finding an actual answer. I'm finding an estimated answer. In this case, we know that to estimate, we've learned about rounding, so that's how we are going to estimate. Yes, sorry.
Would you like us to write that?
Yep. Remember, anything I write on the board, you write too, unless I say, don't write this. Now the word altogether is also important because it tells us we are putting these numbers together, not taking one away from the other. We are putting them together, which means we're doing what operation? Colin?
Adding.
Addition. So all together tells us we're putting these groups together into a bigger number, which means we are adding. Now, did this question tell us where to round our number to when we're estimating? Michaela? No. So that means we get to choose. But because this is an example, your book has chosen for you. But when you get to everything else, you may get to choose yourself. It may tell you, you may get to choose yourself. And we'll talk about choosing yourself in just a minute. So the directions say, the book tells us that what we do in this situation is first, we have to estimate 5,481 plus 2,326. Our book has decided that we are going to round to the hundredths place. So we need to round each number to the nearest hundred, then add. When it says about how many forks and spoons will they need altogether, you're not going to add it and then round the answer. You're going to round each piece of information, each addend. Remember, the two parts that make up an addition problem are the addends. So we're going to round the addends instead of adding them and then rounding the sum. So first, we need to round 5,481 to the nearest hundred. Well, I know step 1 is I circle the digit in the place to be rounded, which is a 4 in the hundredths place. Step 2 is I underline the digit to the right, which is an 8. Step 3 says if the underlined digit is 5 or above, I add 1 to the circled digit. So I'm going to go 1, 2, 1, 2, spaces over, add 1 to that 4, and I get a 5. So notice how I'm making sure that I'm in the right spot. This hundredths place is not the first digit, it's the second digit in a number, so I need to go to the second box. Step 4 says every digit after the circle digit becomes 0. I have 2 digits after the circle digit, so I'm going to have 2 zeros at the end of my number. Can't forget step 5. Anything before the circle digit stays the same. So we keep that 5. Our unofficial step 6 is to place our commas every 3 digits. 1, 2, 3. 1. Don't need another one. Now I'm going to do the same thing with our other addend. Whenever I'm estimating to solve addition or subtraction problems, I'm going to round to the same place for both parts of the problem. I'm not going to round to the thousands here and the hundreds here. I'm going to round to the same place for both pieces of information. So, for 2,326, again, I'm going to circle the digit in the hundreds place, which is a 3. I'm going to underline the digit to the right, which is a 2. Step 3 says 2 is 4 or less, so that means I keep my circle digit the same. My circle digit is the second digit in the number, so I'm going to put it in the second box over here. It's going to stay the same, so it'll be a 3. Step 4 tells me to put 2 zeros at the end of my number. Step 5 tells me to keep the ones at the beginning the same. So now, instead of having to add every single place here, I have this estimated number. Oh, sorry, unofficial step 6 says put a comma every 3 digits. 1, 2, 3, comma, 1. Don't need another one. Now, I don't have to add every single place because I've estimated. And I automatically know, because of the identity property, if I'm adding 0 plus 0, what is my answer, class?
0.
0.
I'm doing that twice. I want everybody to notice. Both addends have 2 zeros at the end. That means no matter what, if both addends have 2 zeros at the end, no matter what is happening, no matter what any of the other digits are, or no matter how many other digits there are in this number, if I have the same number of zeros at the end of both addends, that means at the end, not in the middle or at the beginning, but if I have the same number of zeros at the end of both addends, my sum will have that same exact number of zeros. So my first addend has 2 zeros at the end. My second addend has 2 zeros at the end. So no matter what, my sum will have 2 zeros at the end, always. Now I can just add in the hundreds and the thousands place. Class, what is 5 plus 3?
8.
8. We don't have to do any regrouping there because our answer was under 10. Now I need to add in the thousands. 5 plus 2 is?
7.
7. Now I need to do my unofficial last step, and I need to place my commas every 3 digits. 1, 2, 3. 1. I don't need another one. So that means 5,481 plus 2,326 is about 7,800. So that means the answer to my question about how many forks and spoons will they need altogether is about 7,800 forks and spoons. So is everybody with me so far? You're just rounding 2 times, adding a couple places, and then getting an answer. When you're ready, put your finger or pencil on example 2. Don't rush to be ready. Finish what you're doing, but just know that you need to do this in a timely fashion. You can't just go super slow on purpose. When I see everybody on example 2, we will continue. When I see everybody with their finger or pencil on example 2, we will continue. Okay, read in your head while I read out loud. estimate $7,542 minus $3,225. Now it says estimate, and then it says round to the hundredths place. This is not a real world problem, because is there a real life thing that could happen happening here? Like needing forks and spoons. Class?
No.
No. So that means I don't have to go back and put boxes around important information, because if it's not a real world problem, it only has important information. But it does say estimate. So am I finding an exact answer, class?
No.
No. It tells me to round to the hundredths place. So now I know what to do. Am I going to add and then round the answer to the hundredths place? Am I going to add or subtract these numbers and then estimate the answer? Smith? No. Sorry, make sure you turn yourself on mute. No, I'm not. I'm going to go and I'm going to round the two pieces of my subtraction problem. Remember, the first part is the minuend, the second part is the subtrahend. The answer is the difference. And when we get to the the lesson that's only on subtraction, I'll tell you why. Why does adding have the same word for both their parts? Subtraction doesn't. Well, we'll find that out later. So first, I'm going to take $7,542. I know I'm rounding to the hundredths place. So step 1 tells me to circle this 5. Step 2 tells me to circle the 4 that's immediately to the right. Step 3 tells me that since 4 is 4 or less, my circle digit, the 5 stays the same. 1, 2, the 5 is in the second place. So I'm going to put it in the second box. Step 4 tells me I need 2 zeros at the end. And step 5 tells me there will be a 7 at the beginning. Unofficial step 6 is to place commas every 3 digits. 1, 2, 3, comma, 1, don't need another one. And also to place my dollar sign if I have one. Where does a dollar sign always go? At the beginning or the end of a number? Michaela? Beginning, always. Okay, now I've got my minuend. Now I need to round my subtrahend. Well, step 1 tells me to circle the 2 in the hundredths place. Carla, focus. You can ask me your question in a minute. Step 1 tells me to circle my 2 in the hundredths place. Step 2 tells me to to underline the 2 directly to its right. Step 3 tells me that this 2 in the hundredths place is going to stay the same because our underlined digit is 4 or less. This 2 is 1, 2, the second number, so I'm going to put it in the second box, and it's going to stay the same. Step 4 tells me I'm going to have 2 zeros at the end of my number. Step 5 tells me there's going to be a 3 at the beginning. Unofficial step 6, place my comma and my plus sign, my comma and my dollar sign. 1, 2, 3, comma, and dollar sign. Now I'm ready to subtract. Well, just like addition, if both pieces of my problem have the same amount of zeros at the end, the answer will be the same. It's exactly the same in subtraction. My minuend has 2 zeros at the end. My subtrahend has 2 zeros at the end. So that means my difference, no matter what, is going to have 2 zeros at the end. Because 0 minus 0 is what, class?
0.
And 0 minus 0 is what, class?
0.
0. So no matter what, if both pieces of my problem, whether I'm doing addition or subtraction, have the same number of zeros at the end, my answer, whether I'm doing addition or subtraction, will also have that same number of zeros, no matter what. So do I even really have to do the math in these two places, the 1s and the 10s here?
Nope.
No, because I already know it's going to have a 0, no matter what. If the last 2 digits in both of my pieces of my problem are 0, then the last 2 pieces of my difference will also be 0. Now, I just need to move to the hundredths place. and subtract. 5 minus 2. Can we do that, class?
Yes.
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 What is 5 minus 2? Class?
3.
3.
Michaela, we are subtracting, so listen, not adding. Pay attention to the symbol. Circle the symbol if it helps you to remember, hey, I'm subtracting here, not adding. Now I can move to the thousands place. 7 minus 3. Can I do it?
Yes.
Yes.
I have a smaller number on the bottom, which means I can do that. What is 7 minus 3, class?
4.
4. Unofficial last step, place my commas, 1, 2, 3, and my unit, which in this case is dollars. So, 75,000 minus 32,000 is $4,300. So that means $7,542 minus $3,225 is about, not exactly, $4,300. Any questions on what we're doing? Carla, do you have a question or is your hand just up? Okay. Okay. Thumbs up if you're ready to move on to example 3. You can put it in front of your face. That looks like a sideways thumb. Just know, like if you do this, it looks sideways and then I'm not sure. Is it up or down? Or are you not quite sure if you're ready? You can do it in front of your face. Remember, this is sideways. This is not up. So it tells me, you're not sure. So are you, okay, well we're going to do another example and then we can do another one if we need to. Okay. Helper number 1. Sanitize, erase, sanitize. Everybody out? Everybody, finger or pencil on example 3. When I see everybody's finger or pencil on example 3, we will continue. When I see everybody's finger or pencil on example 3, we will continue. Okay. The problem says we're going to read it once before we put any circles or boxes around important information, then we're going to read it a second time to figure out what our important information is. The table shows populations for 2 cities in Kentucky. About how many more people live in Covington than in Ashland. So, let's read it again and find the important information. The table shows populations for 2 cities in Kentucky. So that means 21,510 is important. 42,811 is important. Then it says about how many more people live in Covington than in Ashland. First of all, we know the about tells us we are not finding an exact answer. We are estimating. So about tells us to estimate. Now this is where it's a little confusing because how many more means we're figuring out what is the difference in the numbers for the people in Covington and the difference for the numbers in the people in Ashland. So we are not taking these 2 numbers and combining them. We're trying to figure out how many more people are there here than there are here. Whenever you see how many more, it means you are subtracting. Anytime you see how many more, or how many less, or how much more, or how much less, you are always, always subtracting. How many more, how many less, how much more, how much less, always means subtract. So that's something you need to memorize. How many more, how many less, how much more, how much less means to do what, class?
Subtract.
Subtract.
Okay, again, our problem doesn't tell us where to round to. So if we were not doing this as an example, where our book and me are modeling how we're thinking, you would get to choose where to round to. But our book tells us to do it. So now, what we need to do first is we need to round each population to the nearest 1,000. Then we're going to subtract. That tells us don't subtract first, then round the answer to the nearest 1,000. Because that doesn't help us to do it a little easier and a little quicker, does it?
No.
Because we won't have any zeros that are easy to just move to the answer. So first, notice how even though the table gave us Ashland's population first, we put Covington's population first in our problem. Why is that? Why did we put, even though our table gave us Covington's population last, why did we put it first in our problem? Zari?
Because it's the greater number.
It's the greater number, and with subtraction, the greater number always has to come first. Because if I have 21,510 pieces of candy, can I give you 42,811 pieces of candy?
No.
No.
No, I don't have enough, so I can't give away this many if I don't have enough. So whenever we're subtracting, the larger number has to come first. Otherwise, it won't work. We won't be able to do it. So, that's why they put Covington's population on top and Ashland's population on the bottom. So, when we're rounding, step 1 tells us circle the digit in the place we're rounding to, which in this problem is the 2 in the thousands place. Step 2, underline the digit to the right, which is an 8. Step 3, our underlined digit is 8. That means it's 5 or more. So we add 1 to the circle digit. 1, 2, our circle digit is the second digit over. So we're going to move to the second box. Change our circle digit to 3 because we had to add 1. Now step 4 tells me there will be 1, 2, 3 zeros at the end of my number. Step 5 tells us there will be a 4 at the beginning. Step 6 says put our commas every 3 digits. 1, 2, 3, comma, 1, 2. Don't need another one. Now, are we just going to subtract 21,510 from this number? Colin?
No.
No. Are we going to round this second part of our problem to a different place than the first one? Colin?
No.
No. Because then we're not making it any easier on ourselves, and estimating, we're trying to make it a little easier on ourselves. So we're going to do the same thing with 21,510. Step 1, we're going to circle the 1 in the thousands place. Step 2, we're going to circle the 5 to its right. Step 3, 5 is 5 or more, so we're going to add 1 to the circle digit. The circle digit is 2 digits over, so we're going to go to the second box. We're going to add 1 to our circle digit to make 2. Step 4, we have 1, 2, 3 zeros at the end of our number. Step 5, we have a 2 at the beginning of our number. Unofficial step 6, 1, 2, 3, comma, 1, 2, nothing. Okay, now I'm ready to do what operation? Class?
Subtracting.
Subtract. We have a subtraction. Oh, do we have to do math in the ones, tens, or hundreds place? Zadie?
No.
No, because we know both of our numbers have how many zeros at the end?
2.
Look at them. Both of our numbers have how many zeros at the end? Zadie?
0.
How many zeros are at the end of both of our numbers?
3.
3. 1, 2, 3. 1, 2, 3. So how many zeros are going to be at the end of our answer?
3.
3. 1, 2, 3. Because 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 0 is 0. But we can just go ahead and place those 3 digits, those 3 zeros. Now we come to the thousands place and we subtract. 3 minus 2 is what, class?
1.
1. Then we go to the 10,000s. 4 minus 2 is what, class?
2.
2.
So that means Covington has about, oh wait, sorry, last step, 1, 2, 3, comma, 1, 2, nothing. Covington has about 21,000 more people, we're going to finish this sentence, than Ashland. So that we know, we're saying this number is about 21,000 more than this number. So remember, when you're solving these problems, you're not finding an actual answer. You're not subtracting, then rounding the answer. You're rounding the pieces of the problem to get a rounded estimated answer. Okay. So everybody ready to move on to the guided practice?
Yes.
Okay. Okay, so the directions for the guided practice say, estimate, round each number to the given place value. This sentence, round each number to the given place value, means you don't have to choose. It's going to tell you where to round it to. So, number 1, we have 1,454 plus 335, and we're rounding to the hundreds place. So, Smith, let's see if you can do this without me telling you the steps. 1,454 rounded to the nearest hundredths is what number? You can do the steps on your own, but we're not going to talk them out. Because now we're getting to the point where we don't have to talk them out every time. You have to do the steps every time on your own, but we don't have to talk them out. I don't have to prompt you. So while Smith is doing that, you should also be doing that. So Smith, what's our first addend?
1,500.
Good, 1,500. Oops, I accidentally wrote it wrong. 1,500. Now we have to round 335 to the nearest hundred, which is what, Smith? $300. Now, Smith, how many zeros do we have at the end of our first addend?
2.
How many zeros do we have at the end of our second addend?
2.
So how many zeros are going to be at the end of our answer?
2.
Good. Now all we have left is 15 minus 3, right? Well, let's look at the hundreds. We have a 5 and a 3. 5 plus 3 is what?
8.
Then we go to the thousands. 1 plus nothing is what?
1.
1. 4 of these, and then we place our comma. 1, 2, 3, comma, 1, nothing. As long as there is no regrouping, you can do it sideways like we just did. But if you need to, rewrite the problem to the side, up and down. Do not be afraid to do extra showing of your work. Please, 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 if you need to, set up the estimated problem up and down to the side. That is not a bad thing to have to show a little more work. It is not bad. I'll show you what I mean with number 2. So sorry, Smith, 1,454 plus 335 is about what?
1,800.
Good. Okay, number 2, we have 2,871 plus 427, and we're rounding to the nearest hundred. Aaron, I pulled my stick, but I don't help with math. I mean, I do, but I help with the examples, not the guided practice. That's your turn. Aaron, so first we have to take 2,871, round it to the nearest hundred, which is what? Please show your work and do the steps yourselves, but we're just not going to talk it out because you've memorized them by this point. Use your pencil to show it, to show the steps. We're just not going to talk it out loud because you know the steps. so you don't need to me to keep repeating them and prompting you. So you show the steps. You show that circle and underlining. Every single person. Show those steps.
2,900.
2,900, very good. Plus, what's 427, rounded to the nearest hundred? 400. How many zeros do we have at the end of our first addend?
2.
How many zeros do we have at the end of our second addend?
2.
So how many zeros are we going to have at the end of our sum?
2.
1, 2. Now we just have 29 plus 4. Let's set it up to the side because, can I do that without regrouping? No. Notice how I covered up the zeros and I'm adding what's left. Do you see that? I'm covering up the zeros because I already know what I'm doing with those. And I'm just going to add what's left. What is left? Aaron, 29 plus 4. Good. We still have 10 minutes, so we're fine. So Aaron, now we just need to go place by place. 9 plus 4?
Is 13.
But we have to regroup, right? So we regroup a what?
1.
To the next place. Not always the tens, because technically, is this 2 in the tens place? No, but we're just taking this smaller problem and pulling it out. Now, Aaron, add the next place. 2 plus nothing?
Is 2.
Plus 1?
3.
3. So now we need to take this 33 and move it here. We're not going to move it here. We're going to move it to the beginning because this 29 and this 4 are in front of our 2 zeros. Now let's put our comma. 1, 2, 3, comma, 1, no comma. 2,871 plus 427 is about what?
3,300.
Very good. Okay, number 3. We have $2,746 minus $1,529, and we're rounding to the nearest 10. Uh-oh, are we still adding? No, let's go ahead and circle that so we don't forget. So we don't forget that we just added twice, but we're not adding again. Okay, Zari, you're going to do the steps yourself, but we're not going to talk them out. $2,746 rounded to the nearest 10 is what, Zari?
$50.
Is it just 50?
2,750.
2,750. Don't forget step 5. Good. Now we're subtracting 1,529. What is that rounded to the nearest 10?
$1,530.
Good. 1,530. When I look at your work, I am looking for the circling and the underlining. Even though we're not doing it out loud, I am looking for that step 1 and step 2 because then I'll know if you followed step 1 and step 2, you also followed step 3, 4, and 5. An unofficial step 6. So make sure that when you are showing your work includes circling the digit in the place to be rounded to and underlining the digit to the right. Okay, Zari, how many zeros do we have at the end of our first number? Zari, are you listening? How many zeros do we have at the end of our first number?
1.
How many zeros do we have at the end of our second number?
1.
So how many zeros are going to be at the end of our answer?
1.
1. Good. Now, what do we have left? We have, what number is this? If we cover up the zeros, what do we have? Just read that number. Pretend like that 0 was never there. And what do we have? You're still on mute. You're still on mute.
275.
275, so we're going to write it to the side. Minus, what do we have here? Pretend like that 0 was never there because we've already figured out where it goes.
156.
156. What is it? Not 156, sorry, it's 150.
160.
Zari, keep your sound on so that you don't have to keep stopping until you're done answering. We have 1,530. If we cover up the 0, what is that number?
153.
153. Now I can just subtract. 5 minus 3 is
2.
7 minus 5 is
2.
2 minus 1 is
1.
Now I need to move this before or after my 0, Zari?
Before.
Good. So I'm going to move that number. Now unofficial step 6, place my commas, 1, 2, 3, comma, 1, no comma, and my unit, which is a $. So Zari, $2,746 minus $1,529 is about how much?
1,220 dollars.
There you go. Okay, last one, and then after library, you'll have time to do the independent practice. We have 48,344 minus 7,263. Michaela, 48,344 rounded to the nearest thousand is what? So do the work and then tell me what it is. Make sure you're circling and underlining. Okay, Zari, go ahead and mute yourself now. You're just going to keep yourself unmuted while you're answering questions. Can't hear you. 48,000. Now, 7,263 rounded to the nearest thousand is what? Solve it on your own and then tell us what it is. 7,000. Now my first number has how many zeros at the end? And my second number has how many? So my answer is going to have 3. 1, 2, 3. Now Michaela, let's cover up the zeros because I've already figured out what to do with them, right? I've already used them. I'm done with them. What do I have? Pretend those zeros were never there. And what do I have? 48. So I'm going to write 48 to the side. And then if I cover these zeros up, what do I have? 7. So I'm going to write 7 to the side. Remember, I line it up along the right. I'm subtracting. So now I can just subtract this much easier problem than this. 8 minus 7 is 4 minus nothing is. So now I need to move this 41. Am I moving it in front of the zeros or behind the zeros? In front of the zeros. Now I need to place my commas. 1, 2, 3, comma. 1, 2, no comma. 48,344 minus 7,263 is about 41,000. Very good. Okay, so go ahead and leave your math books where they are.